Good morning once more, students. The second part of this lecture is how to write a chemical formula. One of the most interesting, one of the most complicated, I would say, and sometimes it's difficult to understand some part of it. And usually it's not taught, I guess, in this state to the students how to write a chemical formula, and this is what is the difficulty that remains throughout along with our students in terms of chemistry. I'm talking about symbols. Number one, it has 5 steps. Step 1, symbols of two elements are written side by side in the order of positive ion first and negative ion later. You can see equation, a balanced chemical equation written here. Symbols of two elements are written side by side. First positive ion, then negative ion. In order to write a balanced chemical equation or a chemical formula, that is step 1. Can you repeat? The symbols of elements are written side by side in an order of positive ion first and negative ion later. Then number 2, the valency of each ion is written at the top right corner of its symbol. For example, you see I'm standing this way. This is my left, this is my right. Okay. This is so precious left, and then this is the right. Okay. Now this is right. Okay. Right corner. Can you see? The symbol is written at the right corner. This symbol is written at the right corner as well. This is valency. The valency is written at the top right corner. You see here oxygen. Valency is written at the top right corner. So that means first point is the symbols are written side by side. Positive ion first, negative ion later. Step 2, very easy. The valencies are written at the top right corner. Step 3 is even easier. It's not difficult. This valency of each ion is brought. Brought means taken to the lower right corner. That means this is top right corner, this is the lower right corner. This is top right corner, this is the lower right corner. Lower right corner of the other ion, but this means by cross exchange method. So that means it's not going to happen in the way we are expecting. This valency is going to become here, and this valency is going to come here. This way, cross exchange method. You can see here this valency of calcium, that is 2 plus, is going to come under chlorine or chloride ion, and this valency of chloride ion is going to come under calcium. So now what is the formula going to become? It's going to become as CaCl2. Okay, so that means step 1 was symbols of the elements are written side by side. Step 2, valencies are written at the top right corner. Step 3, these valencies are brought to the lower right corner through cross exchange method. So that means valency of one element is going to come under another element. That is called cross exchange method. Now, if the valencies are same, this is interesting. If the valencies are same, they are offset. Offset means they are cancelled and are not written in the chemical formula. Likewise here you see valency of sodium is 1 plus, valency of chloride is -1. So that means they are cancelled, they are offset. So when you write a chemical formula as NaCl, no valency is written because they were same, they are cancelled. But if they are not same, they are written, already described, Ca2 plus, chloride -1. It has become CaCl2. Reason, this valency of calcium has come underneath chlorine. Okay. And of course it's not a balanced chemical equation. I have to use 2 here, okay, in order to make it balanced. If I want to make it balanced, I will have to put 2 here, okay, because 2 atoms of or 2 ions of chloride are required in order to make it balanced. So it's a balanced chemical equation. Valency of calcium is shifted to the lower right corner of the chloride. So I hope you have some idea about the 4 steps. Firstly, the symbols of the elements are written side by side, positive ion first, negative ion later. Then number 2, valencies are written at the top right corner. Number 3, valencies are brought to the lower right corner by cross exchange method. And number 4, if they are same valencies, so they are cancelled, but if they are not same, they are written. I have told you both examples. Now this 5th point is a little more complicated at your level. If an ion is a combination of two or more atoms, for example SO4, now it's sulfur, this is oxygen, it's a combination of two atoms, so that means it would be called as radical when it is possessing a charge. So that means group of atoms that is a combination. If it's possessing charge, it's known as radical. So that's what is written. If an ion is a combination of two or more atoms, which is called radical, bearing a net charge on it, for example, that means if a group of atoms has a charge on it, that is net charge, so then it is called a radical. So now if you are using instead of simple ion as a radical, so what will happen? That means here the net charge presents or represents the valency of the radical. So that means this charge is representing the valency of this radical. Exchange valencies of radical is written in parentheses. This is parentheses. Usually we say small bracket, big bracket, okay, curly bracket. It's not that way. The like big bracket that you call in mathematics, that is called a square bracket, okay. That you call curly bracket, it's not curly. In mathematics usually we call it braces, okay, or mathematical term. And this is not a small bracket, this is called parenthesis. This is a sign of bracket, parenthesis. Now for example, it's Al, okay, Al, it has valency 3 plus. Its valency is plus 3, okay, 3 plus is the valency of this one. Now when you want to make it balanced, so what will happen? 3 plus would be shifted here and 2 minus will go here, but we don't write plus and minus. So what will happen? Valency of sulfur is being shifted here, it has become Al2, and valency of aluminium is shifted here, it has become AlSO4 thrice, and this is parenthesis. That means this is the valency of the whole of this radical now that is being shifted from aluminium. It's not only valency of sulfur or oxygen. So this is what is, if I have to balance it, so I'll go here for 2, okay, 2 AlSO4 thrice, and here also I will have to use 3, okay. Now 3 radicals are required for 2 ions of aluminium in order to make a balanced chemical equation. 2 things are described or indicated here. 2 aluminium ions, 3 sulfur ions or sulfate ions, and at the same time you see they also are indicating 3 valency shifted here, 2 valency shifted here. So that means point 5 says if the valencies are not same, they are written as one aspect. Second aspect is if it's a radical, so the valency that is shifted, it would be written in parentheses to whole as a to that radical, okay. So there are 5 easy steps of writing a chemical formula. I hope you benefited to some extent. So if I was able to help you somehow, I'm thankful to you. Thank you so much. Stay blessed. God may bless us.